Hello folks, this is the talk through for the paper sat in the first week of lockdown. What I'd like you to do is obviously go through this at your own speed, correct the questions that you got wrong, make sure you're happy with them, and then get back to me with anything that you still think doesn't make sense. This was a calculator paper, so I'll be using a calculator to do it. And yeah, let's go. So, we always start with our multiple choice questions. Circle a word that describes the shaded part. The shaded part is a segment. A chord is the name for the line that goes across. A sector is a slice, so that would be a sector, and an arc is just a bit of the circumference. Circle a number that is in standard form. So standard form numbers need the number at the front to be between 1 and 10, so it's between these two, and they need 10 to be to the power of a whole number, so it's 6 times 10 to the 7. You can have a negative number, but obviously 38 means that's not true. For question 3, I always think this is a good idea to just give them some numbers. So I am going to say that x is 10, and then if y is 1.5 times 10, y is 15. And so the ratio I want is 15 to 10, which would simplify to 3 to 2. So, those ratio questions, just pick some numbers, see what works with it. Finally, 40 as a percentage of 10. So what this means is 40 out of 10. Always write it as a fraction that's given to you, and then to change it to a percentage, you simply times it by 100. That will give you 400%. You can obviously tell that 40 is bigger than 10, so it would have to be bigger than 100%. Really like that you've got that sort of cascading pattern there. Okay, on to some actual questions. So concrete's got a volume and a density. So the formula that we want to use is MdV. It's the medieval triangle. We want to find the mass of the concrete, so that we're going to do the density times the volume. You should always do a check that the units match up. We've got meters cubed and we've got meters cubed, so we don't need to do any adjustments. I wouldn't expect for a 2-mark question that you need to do any adjustments anyway. But later on you might need to change from like centimeters cubed to meters cubed. Units, it's mass, so kilograms. The same concrete is made into the shape of a cylinder and the base has radius 0.5. We want the height. So this is a volume question. So we need to know the formula for the volume of a cylinder. So volume is pi r squared h essentially, or it can be cross-sectional area times height. That would work as well, but remember the cross-section is a circle, which is why it's pi r squared. So 3.8 equals, and then pi times 0.5 squared times h, because we've got the radius as being 0.5. And so to finish off, you would simply need to divide by that pi times 0.5 squared. There's nothing special about what we need to round it to, so let's just type that in. So that gives me 4.83 meters. Yeah, sounds about right. Cool. Okay, number 6. 4 marks for knowing what different sequences mean. Okay, so arithmetic means that you are constantly adding the same amount. Geometric means you are constantly timesing by the same amount. The triangular numbers are the amount of numbers that make up triangles of different sizes. So you basically add a slightly bigger row on each time. The cube numbers are the numbers that make up cube, but they're also like 1 cubed, 2 cubed, 3 cubed, etc. And the square numbers are obviously 1 squared, 2 squared, 3 squared. You need to know all of these definitions. And Fibonacci, which we don't use, means you add the last 2 numbers together. So the reason that's Fibonacci is because 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, etc. So arithmetic progression, always adding the same amount. That's 1, 2, 3, 4, 5, 6, because we're always adding 1. This one's geometric, because we're always timesing by 2. The triangle numbers are 1, 3, 6, 10, so that's actually just goes straight across there. The cube numbers are 1, 8, 27, etc. So that's that. And the square numbers are 1, 4, 9, etc. So that's that. Make sure you know the definitions of all of those things on the right hand side. Let's keep going. Theo starts with savings of 18 quid and James starts with no savings. So we've got Theo and we've got James and we start with 18 and 0. It says Theo will save £4.50 a week and James will save £4, and we want them to get to the ratio 15:8. So obviously there's no ratio to start with because you can't do anything with 18:0. But this is like a trial and error question. You add on a week for Theo. You make him up to £22.50 because he's always adding £4.50 and James is at 4. And if you want to write something as a ratio, if you type it in a calculator and just press simplify, as in if you typed in 22.5 over 4 and simplified the fraction, it would tell you 45 over 8. That's a fully simplified ratio, so that is 45 to 8, and you can always just use your calculator to do that. So you sort of keep going for a bit. Let's put a few of these down. Yeah, that's just 16. And let's test these out. So if I do 27 and 8, then that ratio is 27 to 8. That's not what I want because I want the ratio 15 to 8. 31.50 to 12. Does that work? No, that's 21 to 8. It's good that they always end with 8. 36 to 16. No, that's 9 to 4 apparently. The streak is over. Okay, so you have to keep going then. So let's try another couple. £40.50 and £20, £45 and £24. So 40.5 divided by 20, that's 81 to 40. That's not the right ratio because I want 15 to 8. And 45 divided by 24 is 15 to 8. There we go. So that is our answer. Now we need to ask the question, in how many weeks will Theo and James have savings in that ratio? So what were the actual weeks here? This was like the starting point. This was after week 1, 2, 3, 4, 5 and 6. So your final answer will be for saying week 6. Okay. Number 8. Length of each side of a polygon is this. Is 8.4 to 1 decimal place. Find the error interval. So for error intervals, it's basically like the smallest it could be, the largest it could be. 1 decimal place would mean they've rounded to the nearest 0.1 because that's in the first decimal place. And then we want to use, for anything to do with bounds, hat. We want to halve, add, and take away. So we take our 0.1 that we've rounded to, we'd halve it to get 0.05, and we'd add that on and take away. So our error interval will be 8.35 and 8.45. Not 8.44, 8.45, because this less than symbol is saying that we're taking anything that's less than 8.45 but not including. For the perimeter, use the fact it's a pentagon. So each of the sides would have to get times by 5 to give you the perimeter. So we'll take our 8.35 and we'll times it by 5, and that will give us that the smallest this could be would be 41.75, and we'll do the same with our 8.45 and we'll get that the largest it could be would be 42.25. Common mistake people would make on B would be to take the 8.4 and times it by 5 and then do the rounding. With bounds questions, you want to do the error intervals first and then do things with them. Let's keep going. So, population of a city, here's Liam's claim. Normally in a GCSE paper, when there's a claim made, they're generally wrong, and your job is to show that they're wrong. So his claim is that it will increase by the same percentage from 2000 to 2011 as it will from 2011 to 2021. So we don't need to analyze his working particularly, we just need to say, is he right and why? So the way that you find what a percentage change is you use the formula change over original. Let's actually give this a little bit more room to breathe, there's nothing there. So percentage change is equal to change over original times 100. So we want to do that for 2001 and 2011. So that would be from 420 to 480. So the change is 60,000, but let's just say 60 out of 420 and then times it up by 100. That would suggest a 14.2% change from 2001 to 2011. If the population of 540,000 matches his claim, then what would happen 2011 to 2021? We've still got a change of 60, but we've now got an original amount of 480,000. So if we times that up by 100, you get, I think, 12.5%. Yeah, 12.5%. So the amount that the population has changed by is not the same. So what do we need to show? Liam's claim is wrong. So we could say increased by different amounts, different percentages. Liam is wrong. But you need the calculation, you can't just say it. Right, question 10. It gives you a formula for a sphere. This is something you always get given in the exam. Sand fills the container, so this is how much the volume's increasing by. I want to figure out how long it takes to fill. So we need to know what the volume of the sphere is to start with. We've got a radius of 30, so we want to say that volume is equal to 4/3 times pi times 30 cubed. Volume should be that divided by 2. I thought I was making a mistake. Cool. So if we do that, 4 divided by 3 times pi times 30 cubed divided by 2. Sorry, yeah, we'll get that the volume is 56,548. Now it fills at 4,000 per minute, so divide that by 4,000. And we'll get that it takes 14.1 minutes or so to fill. This is less than 15 minutes. So, yes. Another way you could have done that last bit, I suppose, would be to go 4,000 times 15 is 60,000, which is how much it could fill in a quarter of an hour, and then compared it to the 56,000 and said, well, it will be done by then. But either way, yeah, it does take less than quarter of an hour. Okay, Ali throws darts at a target. Here's the results. Work out 2 different estimates for the probability of Ali hitting the target. So you can pick anything you like. I am going to pick Monday and Tuesday. Okay, so for Monday, the chance that he hits the target, well, he throws 20 darts and he hits 15 darts, 15 out of 20. For Tuesday, he throws 30 darts this time and hits 22. There you go. There's the 2 estimates. Easy 2 marks. Which is a better estimate? In my case, it's Tuesday. And in general, if you're asked in probability what is the more accurate result, it's the one that has the larger number of trials. So give a reason for your answer. Tuesday has more throws would be enough, or trials is like the correct stats word to use there. Let's keep going. Right, gradient of a line. So 1 centimetre is 1 unit. I'm guessing each one, yeah, it's a centimetre grid, so each of these is a centimetre. Use this to work out the gradient of the line. So let's draw a triangle, 2 and 4. So the gradient of the line will be 2 divided by 4, because it's change in y divided by change in x, which is 0.5. In fact, the scale is that 1 centimetre represents 2 units. So does that make a difference? Well, if each of these squares represented 2 units, this would go like 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. And so if we drew the same triangle on, this would now be 4 and 8. So it'd be 4 divided by 8 would still be a half. Because you've multiplied like the x and the y by the same amount, essentially it doesn't make a difference. So the answer to part A stays the same. You don't have to do any reasoning, but that's the reason. Okay, on to some slightly trickier questions. So this is an algebraic fraction. If you ever see the word simplify with one of these things, that absolutely means that you are going to have to factorize. So let me talk you through how I would do it. I would first try and take any numbers that they've got out common. So this has got 8 that I can take out the top, x squared minus 1, and this has got 4, x plus 1. Now what can we do with that? Well, x squared minus 1 is a difference of 2 squares. It's x plus 1, x minus 1, because it's just x squared, take away a number. Whereas the bottom is just 4 lots of x plus 1. This is exactly what we want, because we can cancel out those x plus 1s, and we can also divide 8 and 4 by 4. What have we got left over then? We've got 2 brackets x minus 1. Now it says show it simplifies into this form, ax plus b, so you would need to expand that bracket and have 2x minus 2 as your final answer for the 3rd mark. But if you see simplify, if you see algebra fractions, you need to factorize. 14, the solution is between two consecutive integers. So integers are obviously whole numbers. So we try stuff out. So you would write in your calculator, what's 3 squared, what's 3 cubed, what's 3 to the 4, what's 3 to the 5, and you get that that's 9, and that's 27, and that's 81, and that's 243. It's still not big enough because we want 300, so 3 to the 6, that's 729. And these are the two that are either side of 300. So the two integers are 5 and 6. 15. A pentagon is made from a square and an isosceles triangle. We want the perimeter. So what we need to find is this length here, because it's isosceles, so these two are both the same. So what we're going to do is we're going to draw a right angled triangle, and there's angles which sort of tip me off to this. And I can say that that chunk that I've just drawn there is a SOHCAHTOA because I've got a right angle. This is 35 because I can take away 90 degrees from it to get that, because there's like a corner there. This length is 6 because it's half of 12. And that's all the information we need, okay? So we could label this up. We're trying to find x, so that's our hypotenuse we want. We've got our adjacent because it's next to the 35, so that means that we are going to use ka, or cosine. We're trying to find the hypotenuse, so covering that up would tell us that x is equal to 6 divided by cos 35. Let's type that in. 6 over cos 35 is 7. It doesn't say how accurate, but let's go 2 decimal places, 7.32. So the perimeter of the shape would be 12 plus 12 plus 12, that's those three, plus the two x's, so plus 7.32 plus 7.32. And that would give me overall the perimeter of that pentagon being 50.6-ish centimeters. Okay, tree diagram time. Now, we've got this word less than 3. Less than does not include 3. So if I was to write down the things that you could get on a dice, these are the ones that are less than 3. These are the ones that are 3 or more. So this should be 1/3 and 2/3. And this should be 1/3 and 2/3. And this should be 1/3 and 2/3, because the second dice is still a fair dice, doesn't change anything. Work out the probability that both dice land on a number less than 3. So remember, to get the probability of things happening on a tree diagram, you times. So if I want less than 3, I go 1/3 times 1/3. That's 1/9. 1/3 times 2/3. 2/3 times 1/3. 2/3 times 2/3. Okay? Work out the probability that both dice land on a number less than 3. So I want less than 3, that's this one here. That answer is 1/9. Work out the probability exactly 1 lands on a number less than 3. So that would be if I had less than 3 and then 3 or more, or if I had 3 or more and less than 3. So it's these two that I want for part C. And remember, once you've got those numbers, you add those together. So that is going to be 4/9. Okay, now this is a bit of a tricky question. We want to find the surface area of y given the surface area of x, and we've got the volume of x and the volume of y. So we basically, well, x is smaller than y. So let's just visualize them like this. Here's x, here's y. Normally what we want is we want to find the length scale factor. So the length scale factor is like, what do you do to the sides here? But we don't know that because we don't know any of the lengths of the shapes, but we do know the volumes of the shapes. So the first thing we can do is we can find what the volume scale factor is, and you do that by taking the big volume and dividing it by the small volume. So if I do 343 divided by 64, it's not exactly pleasant, so I'm just going to leave it as a fraction, because it's like 5.359 ... It kind of keeps going. The next thing I can do is I can find what the length scale factor is, because the connection between these two is that whatever the length scale factor is, if you cube it, you get the volume scale factor. So if I want the length scale factor, I need to work backwards. I need to cube root it. So let's see, I would want to cube root that answer, and that would give me that it is 7/4, or 1.75. Good. Okay, so that's what happens to the lengths. they get times by 1.75. But it doesn't talk about the lengths, it talks about the areas. It says the surface area is 176, we want the surface area of y. Let's change to green. So to do that, I need the area scale factor. Now the area scale factor is the length scale factor squared. So it's cube it if I want to get the volume scale factor, and square it if I want to get the area scale factor. I think I said that right. Area, square it, volume, cube. So we'd have to find the area scale factor. We'd have to go, okay, well, let's take 7 over 4 and square it, and that would give me 49 over 16, or some decimal. 3.0625. So if I want to get the surface area of y, SA of y, that's going to be the surface area of x times the area scale factor, because that's how much bigger the area's got. So I'd need to do 176 times 3.0625. That would give me that it is 539 centimeters squared. Cool. A tricky question, that one, isn't it? Right, we've got 7 or 8 to go. Right, we want to show that these have exactly one point of intersection. So what that means mathematically, if you have a point of intersection, it means that there is one solution to this equation. Now this is a quadratic simultaneous equation, but it's not a bad one because they're both y equals. So what you can do straight away is you can just say x plus 2 equals 4x squared add 5x squared add 5x add 3, and you've got to solve this now. So how do you solve a quadratic? You make one side equal to 0. So we need to subtract the x, that'll be 4x. We need to subtract the 2, that'll be 1. And we've got 4x squared add 4x add 1. And we basically need to solve this. We need to show that there is one answer here. And there's 3 ways you can do that, really, isn't there? You could use factorizing using your shortcut method. You could use factorizing using the MAM method. Or you could use the quadratic formula. Honestly, it's up to you how you want to solve it. If you do factorize this, you will end up with 2x plus 1 and 2x plus 1 as your brackets, and so we'll get that x is minus a half for both of those, and there you could say one solution. If you were going to use the quadratic formula, you could go that x is equal to minus b plus or minus the square root. So this is like an option here. You could do left or right here. B squared minus 4ac all over 2a. That would end up being minus 4 plus or minus the square root of 0 over 8. So it would end up just being minus 4 over 8 or minus a half. And again, that means there is one solution. Yeah, so if it says like points of intersection, you are just talking about number of solutions. Okay, 19, quite a nice question this, because it gives you a formula, and the job is just to sub in these things into the formula and round your answer to 3 significant figures. So if we want to work out the volume here, we are going to go 0.25 times pi squared times what's b minus a squared, so 30 minus 20 squared, and then the other bracket is b plus a, so times 30 plus 20. What would that be? 0.25 times pi squared. I'm going to simplify this a little bit, and that's 10 squared, and that is 50. So you just type that in. 0.25 times pi squared times 10 squared times 50 gives you 12337.00 ... But it says it wants it to 3 significant figures. The third significant figure is the 3 here. So we round, that stays the same because there's a 3 after it. So our final answer will be 12,300 centimeters cubed. Lovely question, that. Then on to a slightly awkward question. So this is distance, speed, time, I think. Oh, they're walking at the same speed, so maybe not. I think it's just a cosine rule question. So we've got Liz and Tia walking to the shop, so we basically want to know what this length here is. Let's call that x, because if it's longer than 80, then Tia will take longer, and if it's shorter than 80, then Tia will take less time. So yeah, this is a cosine rule question. And the cosine rule question is that, let's sort of label this up. So this always takes a while to change colour. That's A, that's A, that's B, that's C. So you always have like sides opposite angles. That's why I'm calling them both A. And the formula is B squared plus C squared minus 2BC cos A. So we need to work that out. We need to go 80 squared, add 60 squared, minus 2 times 80 times 60 times cos 75. And that gives you 7,515 ... But that's x squared, so we obviously need to square root it, and we'll get that x is 86.7 meters. Because of that, Tia's got a longer distance to travel than Liz does. So who will arrive at the shop first? It'll be Liz, because she's got less distance. In fact, Liz walks at a faster speed than Tia. How does this affect? Well, it doesn't affect the answer at all, because Liz has got less distance and she's also walking faster, she will still arrive on time. Okay, cuboid, volume, length, nearest centimetre. Okay, so this is bounds, so this is another of that HAT thing I was talking about. Halve, add, take away. You know? So, first thing we need to do is we need to sort of round it. So the 50, so because it's nearest centimetre, that's the nearest one. We'd want to go 1 divided by 2 is a half. And then if we sort of add or take that away, we can get what the range of the measurements are. So the cuboid is somewhere between 49.5 to 50.5 tall, 34.5 to 35.5 long, and 19.5 to 20.5 deep. So we want to basically multiply these together, and we want to see which is bigger. So you have to think what's the smallest this cuboid could be and what's the biggest it could be. So the smallest it could be would be if we took the small numbers. If we did 49.5 times 34.5 times 19.5, which would be 33,301 centimeters cubed. A lot of volume on this question, isn't there? And the largest it could be would be if we took the big numbers, 50.5, 35.5 and 20.5. If we times them together, you'd get 36,751 centimeters cubed. And then the container is exactly 34 litres. So that was the cuboid. For the container, it's just 34 litres, and each litre is 1,000 centimetres cubed. So if we want to compare it, that will tell us it's 34,000 centimetres cubed. We want to say which is bigger. Now it depends, doesn't it? Because if the cuboid is its largest amount, then it's bigger. If the cuboid is its smallest amount, then it's smaller. So it could go either way, and that's our proof. Okay, 3 to go. Venn diagram. I remember this one being quite difficult. The probability that a physics student chosen at random also studies chemistry is 5/12. So that's like this bit here. If we take a physics student at random, there are 35 plus x of them. And also studies chemistry is x. So that first line would tell us that x out of 35 plus x equals 5/12. Yeah, I think that's what we have to do, isn't it? So what we're going to do is solve this equation. So we will cross multiply, which will tell us that 12x equals, so 5 times 35 is 175, 5 times x is that. We'd then subtract 5x to get 175, and we divide by 7 to get 25. So we can work out there that x is 25. guess you could check if that still goes to 5 over 12. Yeah, that's 25 out of 60. Yeah, that's fine. Okay, we then need to work out what y is. Now for that, we use the fact that there are 150 students in total. So because there's 150 students in total, that would tell us that 47 plus 25 plus 35, which are the three numbers we know, plus y equals 150. And if we take those away, that would be y is 43. Okay, work out the probability a student does not study chemistry or physics then. So our final answer would be, well, there are 43 that don't study either out of 150 total. There's our answer. That initial setup is tricky though, isn't it? Because we had to narrow it down to the 35 plus x that studied physics and the x that studied chemistry and physics, and compare that and multiply it. You could do a little bit of trial and error, I suppose. You could try different values of x and see which one's simplified to 5/12 like we did in the ratio question. Something to think about. Okay, 2 to go. Prove algebraically this converts this fraction. Now I think this is a really cool little method, and I think this is a nice question to have towards the back of a paper. This is how it works. We say x is equal to 2.75555 ... and then we multiply it. So I'm saying 5555 because the dot's just over the 5, it's not over the 7 as well. And there's one repeating digit. So because there's one repeating digit, you just times it by 10. If there was two repeating digits, you'd times by 100. If there was 3, you'd times by 1,000. And if we times that by 10, we get 27.55555 ... And what we're going to do is we're going to subtract this. So I'm actually going to do it the other way around. I'm going to do the 10x take away the x, and that will give me 9x. And then I'm going to do 27.55555 take away 2.75555. And you've just got to remember that like all these 5s will cancel out. And you're just doing 27.5 take away 2.7, which will give you 24.8. And then we want to get what x is, so x is 24.8 over 9. Now have we proven what we need to prove? No, because we need to show it's the fraction 124 over 45, not 24.8 over 9, but what would you do to make 9 into 45? You would times it by 5, and if you do the same with 24.8, you get 124. Okay, last question, functions. This was part A, by the way. Don't know how I managed to cut that off. So we're told that f is equal to 5 minus x and g is equal to 3x plus 7. And we want to simplify these two fractions. So let's work them out first. F of 2x means if I take 2x and put it where x is, what would I actually get? So if I swap in a 2x for x, I have 5 minus 2x. G of x minus 1 is what if I took x minus 1 and put it in place of x. I would end up with 3 lots of x minus 1 instead of 3 lots of x plus 7. I'm actually going to expand that and simplify it to 3x plus 4, because what the question wants me to do here is to take those two and add them together. So let's do that. I've got f2x plus g of x minus 1 there is equal to 5 minus 2x plus 3x plus 4. Collect your terms, so 5 plus 4 is 9, and minus 2x plus 3x is just x. So x plus 9 would be your final answer. Again, honestly, for the end of a GCSE paper, not too bad. Lastly, we've got to solve that an inverse of g is equal to 2x. Now, how do you find an inverse? So the steps are this. You want to first set whatever your function is equal to y. You want to rearrange to x equals, and then you want to swap basically x for y. So let's do that. Set gx equal to y. So gx was 3x plus 7. So we're going to go 3x plus 7 equals y. We're going to rearrange it to x equals, so think Metford, Collect would be the first thing we do because there's no brackets to expand, no terms to collect, so so we'll have 3x equals y minus 7. Factorize, nothing to factorize. Divide, x equals y minus 7 over 3. And then swap x for y. So our inverse function is this. G minus 1x is x minus 7 over 3. But that's not the question finished because it wants us to solve this. It wants us to solve the inverse is equal to 2x. So we take our x minus 7 over 3, we set it equal to 2x, and this is the equation to solve, which is just a linear one. Again, we can use method. Multiply, so we'll end up with x minus 7 equals 6x. Expand, nothing. Collect, so we'll end up with 5x is minus 7. And then divide. X is minus 1.4, and that is our solution for B. Okay, I hope that helped. Again, please do ask me if you are stuck on anything there. Whole point of this time is that I can help you out. See ya.